This video is about joint variation, which, unlike direct and inverse variation, where they have a specific model, direct variation is just a linear relationship, and inverse variation, we have this y equals k divided by x, or inverse relationship. Joint variation, on the other hand, just means that more than one thing is involved. It's a more, it opens up some diversity as to what these equations are going to look like. Let's tackle the first problem. S varies directly as the product of x, y, z. So that means direct variation we're multiplying by that. It's a more, I shouldn't say linear relationship, but we're multiplying by our variables. So S varies directly would be S equals K times X times Y times Z. That's what that first mathematical model would look like. For the second problem, we're told that Y varies directly as X and inversely as the square of Z. So Y equals K times X, there is the directly as X, and inversely, so I'm going to be divided by the square of Z. That is Z squared. The applications of joint variation are all over the place, because in more complicated situations, this variation changes. The gravitational pull of two objects, they vary not just with the mass of one object and the force of gravity, but they vary with the mass of either object, well, both objects, and the pull of gravity, and the distance the objects are apart. The light from stars follows something called the inverse square law, which is that light decreases, so inversely, by the distance squared, not just by the distance. Let's do this problem. The amount Q of water emptied by a pipe varies directly as the square of the diameter d of that pipe. Let me highlight some of this. So the amount Q of water emptied by a pipe varies directly as the square of the diameter d. So a pipe 5 inches in diameter will empty 225 gallons of water over a fixed time period. If we assume the same kind of flow, how many gallons of water are emptied in the same amount of time by a pipe that's 9 inches in diameter? So I want to first build our equation of variation. I see that Q varies directly as the square of D. So Q equals K times D squared. There's our model. Now we want to find what K is. A pipe 5 inches in diameter will empty 225 gallons. We're going to plug that information in to find K. So 225 equals K times 5 squared. If we divide both sides by 25, and I got 25 from 5 squared is 25, 9 equals K. So that means our equation has become Q equals 9 times the diameter squared. Now the question we want to answer is how much water is emptied in the same amount of time by a pipe that's 9 inches in diameter. That is, we want to find Q when the diameter is 9. So this first 9 is our K, and 9 squared, that's our diameter squared. 9 times 9 is 81, and then times this third 9, it's 729. So in that same amount of time that the smaller pipe empties 225 gallons, the larger pipe empties 729 gallons. Thank you.